Hello everyone. Yesterday I have updated the results of assignment 4. And you can take a look of the results. One common mistake about this assignment is that many students forget to initialize variables. And if you forget to initialize variables, your program may work properly on your computer, but this cannot guarantee your program to work properly on other computers. And I suggest that before sending your solution, you had better test all the input-output samples. If your program can pass all the input-output samples, then the accuracy of your program will be 100 or near 100. And I also, and the deadline of assignment 4 is today, 12 p.m. So if you have not sent your solution, remember to send your solution before 12 p.m. today. And I also updated the results of assignment 5. And the assignment 5 also have 2 tasks. I also suggest you test all the input-output samples. And if your program can pass all the input-output samples, then there is a high probability that your program is correct. And we are near the end of the semester. I will announce the information about the final exam maybe in this week or the next week. And we have finished the introduction of strings. And in this week, we will learn how to sort words. So this chapter is very short. It is about how to sort words, how to sort strings. And given two strings, for example, bear and camel, and we can compare which one is larger. And the rule is that if the first character, if the first letter of the first word is less than the first letter of the second word, then the first word is less than the second word. So for example, bear is smaller than camel because its first letter B is smaller than the first letter of camel. The first letter of camel is C. And how to compare the order of letters? How to compare letter B with letter C? If a letter is closer to A, then the value is smaller. If a letter is closer to letter Z, then the value of this letter is larger. So letter B is smaller than letter C. And therefore, the string BO is less than the string camel. And the next example is, for example, we want to compare BO with bell. And the first letter of the two words are the same. So we need to compare the second letter. For BO, the second letter is I, and for bell, the second letter is E. And we need to compare letter I with letter E. And we need to compare letter I with letter E. And because letter E is closer to letter A, so letter E is smaller than letter I. So BO is not smaller than, it's not less than bell. So if we print if we print the value of this comparison, the value is 0. Because BO is not smaller than bell. So if we print the value of this Boolean operator of this comparison, then the result is 0. And if we print the value of if we print the value of BO is smaller than camel, then this comparison will yield true. So the value is 1. And you can write some simple program to verify how to compare two strings. In this example, I declare two strings. The first string is S1, and its value is the C string BO. And next I declare another string S2, and its value is a C string Alex. And we want to compare the two strings S1 and S2. And the result is 0. If we print the value of this comparison, then the result is 0. Because BO is not smaller than Alex. and because letter B is larger than letter A. And next, for example, I change S2 to Bell. The result is also 0 because the order of the first letter is the same, and we need to compare the second letter. So we compare letter I with letter E, and letter I is greater than letter E, so Bill is greater than Bell. So this comparison operator will yield 0. And we need to include the parentheses here, because if you omit the parentheses, this will lead to a syntax error. Because for this statement, the precedence of this shift operator is higher than the less than operator. So if you do not add a parenthesis, if you do not add a parenthesis around S1 less than S2, if you don't do this, then the compiler will evaluate the first shift operator first. But so the compiler will first evaluate count and left shift S1. But after this expression, then the compiler, the program will return. The compiler will try to perform less than S2. Then this will lead to syntax error. So if we want to show the value of S1 is less than S2, then we need to include parentheses. Next, I show we can use the sort function to sort a vector of strings. So in this example, I declare a vector of strings. So I use the data type vector, and each element is a string. I use this data type to declare a variable names, and this vector has 6 C strings. The first string is Bill, and the second string is camel, and so on. And we want to sort this vector of strings, and we can use the sort function. So for this example, we can you can copy this statement. for this example, I declare a vector of strings, and the variable name, the variable is names, and this vector has 6 strings. Then I use a for loop to print the element of this vector. So the element of this, the elements are Bill, Camel, Alex, Alexander, Itela, and Iranda. And we want to sort this vector. We want to sort this vector. And to sort this vector, we can use the sort function. And this function is in the algorithm library. So we also need to include the algorithm library. And for this function sort, we need to specify 2 inputs. The first input is a pointer, point to the first element we want to sort. And the second input is also a pointer. And this pointer will point to the last element we want to sort. And after this statement, we also use a for loop to print the element after sorting. So before sorting, the 6 strings are in this line. And after sorting, the results are in this line, and we see that strings, if the value of the string is smaller than the string Alex is in the is the first element after sorting, because the value of the value of this string is the smallest, and the Itela is the last element after sorting, because the value of this string is largest, and the sorting is performed in the ascending order. So the value is from smallest to largest. And the next we will talk about the more advanced usage about sort. For example, in the previous example, we sort strings in alphabetical order. And now suppose we want to change how to, now suppose we want to perform sorting by string length. So if we want to perform sorting by string length, then this means the value of the value of strings with more letters. For this example, Alexander is greater than Zitella because Alexander has more letters than Zitella. Alexander has 9 letters, while Zitella has 7 letters. So if we perform sorting by string length, then Alexander is greater than Zitella. And Camel is greater than Bill because Camel has 5 letters, and the Bill has 4 letters. And the value of Bill and Alex are the same because the two strings are of the same length. And if we want to perform sorting by string length, then we need to provide a compare function to the sort function. In the previous example, the sort function only has 2 inputs, and in this example, the sort function has 3 inputs, and the third input is a compare function. This function defines how to compare two elements. And I will show how to define a compare function. This is the compare function, and this function has 2 inputs. This function compare 2 elements of this vector, and because each element is a string, so the data type of the 2 elements are string. And here we use call by reference, so we add a AND operator. And because we do not modify the value inside this function, so we add a const. We add the const modifier. And this function returns how we compare the 2 elements. You can rewrite this function as you can rewrite the function like this. First, we compare str1 with str2, and we save the result of this comparison in the Boolean variable CF. Then we return this Boolean variable. And you can also, but this is a bit redundant. We can omit the CF Boolean variable, so we can only use this simple statement. So this line is equivalent to the above two lines. We can return the result of this comparison operator. And now in this example, I add a compare function as the third input of the sort function. We see that after this sorting, after this function, the result is Zitella, Yolanda, Camo. This is sort in the reverse order of the reverse alphabetical order, because Z is the strings with the first letter Z is in the first element. So this is the reverse alphabetical order. And we can change the order by reverse this sign. For example, if we change the greater than to less than, then the order is changed. Now the order is in ascending order. While previously, if this operator is greater than, then the order is in descending order. So this function, this function determines how we compare two elements of a vector, and we can customize this function to affect the result of sorting. And now suppose we want to sort according to string length. Suppose we want to sort the vector by string length. Then we can provide a customized compare function. I changed the function name. You can use any function name. So I changed the function name to compare length, and we need to change this statement. So I compare two elements, and the order is determined by the length of each element. And previously the order is determined by the alphabetical order. So I use this statement to compare the order of two elements, and we can use this compare function as the third input of the sort function. And let's see that now the sorting results are in this line. Alex is the first element because the length of Alexander is the largest, and Alex is the last element because the length of this string is the smallest. And you can, if you want to reverse the order, you can change the greater operator to the greater than operator to less than operator. Then the order of this the order of the sorting results is in the ascending order. So we can give a compare function to the sort function, and to determine how to compare two elements. And if you want to run this example, you can go to the reference web page, and in this web page you can find the strings. You can go to the sorting item and find this CPP file. This file is to test bubble sort, but you can remove the bubble sort because we do not introduce bubble sort, but you can test other sorting function, other examples about the sort function. Next, this is the last page of this slide. We will talk about stable sort and unstable sort. And sort is to sort. For this example, sort is performed in ascending order. And now suppose the input array has two records with the same keys. So for this input array, we have two elements, 5 and 5 star, and the two elements are of the same value. So after sorting, the position of the two elements should be 5 star or 5 star 5. Both two are legal. Because 5 and 5 star are of the same value. So the sorting results is either 5 5 star or 5 star 5. Both two are valid sorting results. And the difference between stable and unstable is that stable sort maintains the relative order of records with equal keys. This means, for this example, 5 and 5 star are of the same values. So the stable sort will maintain the relative order. 5 is before 5 star. So this kind of sort is if in the input array 5 is before 5 star. If the relative order is maintained after sorting, so if the relative order is maintained after sorting, then this type of sorting is called stable sort. Otherwise, if the relative order might not be maintained, then this type of sort is called unstable sort. So unstable sort cannot guarantee the relative order of elements with the same values. Now we have another question. The sort we have used, this sort is stable or unstable. If you think this sort is stable, please raise your hand. If you think this sort is stable. And if you think this sort is unstable, please raise your hand. Oh, okay. The result is unstable. This sort is unstable. So if we use this sort, we cannot guarantee the relative orders of elements with the same values. And if we want to use stable sort, if you want to use stable sort, then you can search the C++ library. For example, you can search then you will find this function, stable underscore sort. For this function will perform stable sorting. And the usage of stable sort is the same as this one. So if you see the usage of this function, this function sorts the element by this function sort the elements specified by the range. The first iterator and the last iterator in ascending order. This behavior is like a sort, but this function preserves the relative order of elements with equivalent values. and this chapter. And next we will go to the next chapter. The next chapter is structures and classes, and this chapter introduces how to define our own data types. This chapter has 3 parts. The first part is structures, and this is inherited from the C programming language. And in the C programming language, if we want to define our own data type, then we need to use structure. And in C++, if we want to define our own data type, we will use classes. And the difference between structures and classes are as below. The structures can only have member variable. The structure cannot have member functions. But for classes, classes can have both member functions and member variables. And the third part introduces object-oriented programming, which is abbreviated as OOP. And first, let's see how to define our own structure. And a structure means a collection of data, a collection of data items of diverse data types. Suppose we want to define a data type, automobile, and this data type consists of three data types. Consists of 3 variables: year, doors, and horsepower. So we can use the keyword struct. Struct means structure. We can use this keyword to define a data type. And usually when we define a data type, we often let the first letter is in uppercase. This is a convention, but this is not mandatory. This is only a convention. And this data type has three member variables. You can change the name. You can change the variable name to meaningful variable names. And when we define this structure, no memory is allocated. Because we are not declare variables, we are not because when we use structure to define a data type, no memory is allocated. Memory is allocated when we use this data type to declare variables. And remember that layer is a semicolon in the end of this statement. And after we define the data type, then we can use this data type to declare variables. For example, we can use this data type to declare a variable car1. And the car1 has three members: car1.year, car1.doors, car1.horsepower. And we can use the dot operator to access the value of a member variable. So if we want to assign a value to the member year, then we can use the dot operator. Next, we will have a survey about the course evaluation. So I will let. So the next we will conduct this survey, and after this survey, you can take a break for about 10 minutes, and then the next hour we will have a quiz.这里都是，这堂是必修嘛，对不对？那大家都是同一班的嘛，那可以，看要不要一个人来扫这个文件，然后传到班群，你们有赖群吗？班群，还是我放到我？那大家帮我扫一下这个 QR code， 有可以继续吗？那登录之后会有2个问卷要填，一个是教学电调查，一个是学习成效什么的。那只要你们就选那个计算机程式，然后归家国老师，然后之后继续填，它就是接着教学兼调查后面就会有一份。对，然后大家尽量就是这3个小时就填一填，因为过了时间好像就不能填了，所以尽量这3个小时就填一填。 Hello everyone, and let's continue our class. And the next we will have a quiz, and raise your hand if you need you need paper. You have 3 minutes for this question. 20 seconds left. And I will close this question. And you have 3 minutes for this question. Uh, 30 seconds left. I will close this question. You have 3 minutes for this question. 30 seconds left. And I will close this question. Please forward your paper to the first row. Let's see the answers. And for this question, the answer is 3. The array size is 10 and the string length is 9. For this example, this is a character array, and this array has new space here. So 8 characters, and the line break \n means line break, and this is only 1 character. So new space here, line break. So in this example, we have 9 characters. But this is a double quote. This is a C string, so the array size need to include the null character. So the array size is its length plus 1. So array size is 9 plus 1. So array size is 10, and the string length is 9. And you can use a simple program to print the array size and the string length. So you can use the size to print the size of a character array, and you can print use strlen to show the length of a string. For this question, the answer is 4, syntax error. because for this statement, there are two plus operator, and the left plus will be carried out first. So we need to evaluate the left plus. So we need to evaluate name1 plus this double quote. But name1 is a C string. Name1 is a character array. So name1 is a C string. And the double quote is also a C string. And the C string does not support the plus operator. So if you try to compile this statement, and the compiler will issue a error message. So the answer of this question is syntax error. But if you change name1, if you change the data type of name1 to string, then this statement becomes legal. So if you change the data type of name1 to string, then this statement will become legal. The answer of this question is 3. For this example, I declare a character array. This is a C string, and I write a for loop, and in each iteration, this statement performs dicti minus character A, and this is legal. We can perform one character subtract another character. This is legal. So letter A minus letter A means it's like integer subtraction. So the result of letter A minus letter A is 0, and the letter D minus letter A, the result is 3, because you can look the ASCII chart. The decimal value of D is 100, and the decimal value of letter A is 97. So if we subtract letter D with letter A, then this is equivalent to we perform 100 subtract 97. So the result is 3. And you don't need to memorize the decimal value, because you only need to compute the relative difference between letter D and letter A. Suppose letter A is in the first position, then letter D is in the 4th position. So their relative difference is 3. So you don't need to memorize the decimal value. So the relative difference between letter D and letter A is 3, and the 3 plus 1 is 4. So the first integer is 4, and you can continue this process to compute the other integers. So the answer of this question is option 3. if you have question about the quiz, you can take a look about the chapter of strings. Then we return to the structures. We introduce how to use the structure to define our own data type, and we can use the dot operator to access member variable. And we can also simultaneously define a structure and declare a variable. So after we define the structure, we can add the variable name. So this statement simultaneously define a structure and declare a variable car1. So this statement is equivalent to we define a structure and we use this data type to declare a variable car1. But we do not suggest writing a program in this way, because we want our program to be readable. So it is better to separate structure definition and variable declaration into two statements. So it is better that your statement only do one thing. This is a better way, because if you try to perform many things in a single statement, then your program becomes less readable, and it is hard to debug your program. Next one is about structure assignment. For example, we can use automobile to declare car1 and car2, and then we assign some values to members of car1, and then if we want to copy the values of car1 to members of car2, then we can use this single statement car1 assigned to car2, and this single statement is equivalent to the following three statements. So this if we assign car1 to car2, then this is equivalent to we individually separate. We assign the individual elements of car1 to car2. So using structure is convenient if you want to perform structure assignment. If you don't use a structure, for example, if you don't use structure, you only use simple data types integer, and the program is like this. You need to declare car1 year, car1 doors, car 2 ear, car 2 doors. And if we want to perform assignment, you need to assign individual variable of car 1 to car 2. But writing program in this way, you need to type a lot of words. But if you use a structure, you can compare the two ways to write a program. The first way is you don't use a structure, while the second way is you use the structure automobile. And the definition of automobile is like this. This structure has two variables. And if you compare the two examples, you will find the second example is more clear. And you don't need to type the naming of the second example is more clear. And this assignment, you don't need to perform individual assignment. And this assignment will copy all the elements of car 1 to all the elements of car 2. Next, we introduce how to pass structure as function arguments. And there are two methods. Method 2 is called by value, and while the method 1 is called by reference. Call by value is the default method. If you want to pass the variable car, and while if we want to use call by reference, we need to add the AND operator after the data type. And if your function does not modify the value of car, then you can add the const modifier. And the two methods are okay for this example. But the first one is more common, because the first method save memory. For the second method, if your data type is very large, for example, if your data type is a matrix of 10,000 elements, then using call by value will waste much memory. So method 1 is preferred, because call by reference is better if you want to pass a large variable. And in this example, the input of this function is a variable car, and the data type is automobile. And this function compute the price based on the car's horsepower and the car's year. Next is about the hierarchical structures. And now suppose we want to deal with person information. And person information include the height, the weight, and the birthday. And the birthday includes year, month, and the day. And we can define a hierarchical structure to deal with this problem. So first, we can define a structure, and the name of the data type is person information. And the data type of height is integer, and the data type of weight is floating point double. And for the birthday, because the birthday has 3 members, so we define a new structure, date. This structure is to deal with birthday. Then we can use the data types to declare variables. For this example, we use person info to declare a variable person1. And then we can use the dot operator to access its member. For example, we can assign 110 to person1 dot height. We can assign 15.5 to person1 dot weight. And to access the member of birthday, we can use dot birthday dot year to assign the birthday year. So this is the use of hierarchical structures. If you don't use hierarchical structures, for example, you can if you don't use structure hierarchical structure, then your structure is like this. You declare person info like this. You need to include the 3 elements: birth year, birth month, birth date. Then your person info will have 5 elements, 5 members. But the 3 members, birth year, birth month, birthday, should belong to birthday. So a better way is to let the 3 variables belong to the data type date. So a better way is to like the example. You define another structure, date, So the better way is you define another structure date, and you can use date to declare a variable birthday. The next slide is about structure initialization. And this is similar to array initialization, so you can take a look of this slide by yourself. The rule is similar to array initialization, so I will skip this slide. And we have finished the introduction of structures. And next we will go to the second part, classes. The main difference between structures and classes is that structures only has variable as members, while classes allows variables and the functions as members. So the members of classes can be variables and the functions. So classes is similar to structures, but the classes aids member functions, and the classes is often used in object-oriented programming. And we often code variables of class types as objects, and an object contains member data and member functions. Member data also called member variables, and member functions also called member operations. So this slide is an example to define a data type, a day of year. And the keyword is class. The keyword is class is a keyword, and the day of year is the name of the data type. So this is similar to structures. But we can also declare functions inside class. So we can declare a function in the definition of the day of year. And in this example, we can use day of year to declare the variable today. And we can use the dot operator to access the member, its member variable. And we can also use the dot operator to access the member function. And inside the definition of this data type, we only give the function declaration, and we also need to give the function definition. So the function definition is usually is below the main function. Let's take a break for 10 minutes. So you want to swap to so what is the purpose of this function?
Because I want to, if the value of the score is smaller than the next, I want to swap to two score. Yeah, in order to sort, and I need to also sort the name. Yeah, so I just want to switch.
This might because your index is outside the range. Yes, your index I should between 0 and score start size minus 100, and your code does the index I might outside the legal range.
Also, it means that I is bigger than
The
outside the range.
because your code does not ensure that I is between 0 and the score start size minus 1. So when running your program, might be at some time I is outside the legal range. So you will see this is often about memory issue, segmentation fault.
Memory.
Hello everyone, and let's continue our class. We can use the class keyword to define a data type, and this data type has member variables. We can also have member functions. And inside the definition of this data type, we only give the function declaration. And we also need to give the function definition. And to give function definition, we need to use this operator, the double column. This is called the scope resolution operator. This is the definition of the function output. And before the function name, we add the scope resolution operator. And this operator specify this operator specify output is belong to the day of year, belong to this class. And inside the function, inside this member function, you can access the members. You can access the data type's member. You don't need to pass the member in the input in the arguments of this function. In this example, I use class to define a data type, day of year. And this data type has two member variable, months and the day. And I also declare a member function output. And below is the definition of this function. In this function, I print the values of months and day. And in the main function, I use the data type to declare a variable dy, and I specify the values of months and day. And then I use dy.output to print the values of months and day. So the output of this program is in this line. one special property of the member function is that you can access the member data. You can directly access the member data in the definition of this function. You don't need to pass the variable in the input arguments. This slide lists the difference between dot and the scope resolution operator. We use the dot operator to access the member variables or member functions. And the scope resolution operator. The scope resolution operator is to tell the compiler this function belongs to which data type. So the scope resolution operator specifies what is the class of the function. What is the class of the function definition comes from. And next we will talk about the public and private keyword. And in the class, in the data type defined by class, we will use two keywords. The first one is public. The second one is private. And in the previous example, we assume all the members are in the public, are under public. And public means we can access the members in the main function. So in this example, if I change the if the member data is not in public but is in private, then if the member data is under private, then we cannot access the member data in the main function because the compiler will issue an error message because month is private. The member variable of day of year is private, and we cannot access this member in the main function because this member is private. So we can only access public members in the main function. So we can call the output function because output function is under the public label. So we can access output function. We can access the output function in the main function. But because the value of months and the day are not initialized, so the value are random because we do not initialize months and day. And later we will show, we will introduce how to initialize member variables. And the data in class almost designed private. So we often put member data under the private label because we want to protect our data. We don't want our user to see the private data. And this is one of the principles of the object-oriented programming. And the only way to access data is to via member functions. And the public items are user accessible, and member functions, usually member functions are public. Below is the difference between structures and classes. For structures, all members are public. So structures has no, the structures in the C programming language, all members are public. So there are no private member variables in structure. And the structures have no member functions. And for classes, typically all data members are private. And interface member functions are often public. And next we will see examples how to define a data type by class. And we will introduce what is an accessor and a mutator. For this example, day of year, and we have two member variables, month and the day, under the private label. And we also have some functions under the public label. And if we want to access the value of day, then we need to write a function. This function is known as accessor. This function returns the value of the member. So for example, if we want to get the value of the member day, then we need to call this function getDay, because we cannot directly access day in the main function, because this variable is private. But getDay is public, so in the main function we can access getDay, and the getDay is a member function, so getDay can access its member data. So we can call the getDay function to access its member data. sorry, int. So I print. I print. I want to access dy.day, but because day is private, so I need to use the function getDay. GetDay is under the public label, so I can call dy.getDay, and this function returns day, and the day is an integer. So I print the value of the day, but day is not initialized. So this is a random number because I did not initialize day. And to specify the value of day, we need to write another function, setDay. And this function is known as a mutator. Mutator modifies the value of the member variable. And the setDay function has one input, new day. And inside the definition of this function, it will assign new day to the member variable day. So I define the function setDay. This is a member function of the data type day of the year. So I use the scope resolution operator to specify that setDay belongs to the day of the year data type. And the function declaration is in the definition of the data type. This is the function declaration. The input is an integer, and there is no output. So the return data type is void. And inside this function, I assign the input new day to the member data. Day is the member variable. We cannot directly access the value of dy.day because day is a private member. So to get the value of the private member, we need to use the accessor. To get the value of the private member, we need to use accessor. While if we want to modify a private member, we need to use the mutator. You can define the previous functions are for day member variable day. You can also define member functions to deal with the member variable months. After we define a class, we can use class to declare variables, and those variables are often called objects. Objects have member functions, and member data. And the data type defined by class is like the built-in data types, like integer, double, or float. Any data type includes any data type includes data and operations. For example, the integer data type. The data of the integer data type is a 32-bit integer, and this data type supports some operations like addition, subtraction, multiply, and division. So we can also define our own class with operations like these operations. This slide is about abstract data types. Abstract means the user of data type do not need to know the details how the data and the operations are implemented. The users only need to know how to use the data type, but the users do not need to know the implementation details of the data type, and this is known as abstract data type. And the one principle of object-oriented programming is to separate interface and implementation. Because user of the class need not know the details of how to implement the class. The users only cares about the interface of the class, and the interface are usually public member functions. For this example, the interface are getDay functions, getDay and setDay functions. The users only cares about how to use the two functions, and the users do not need to know how to implement the two functions. This is called the separation of interface and implementation. And the benefit of this approach is that you can change the implementation without having to change the other parts of your program. For example, the operating system of this notebook is Windows 10. I know how to use its interface. Its interface is like you click some icon or some icon, then you can run some programs. I only need to know how to use the interface, but I don't need to know how the implementation details of these functions. So if I update this operation system, the interface is not changed. If I update the operating system, the interface remains the same, but its implementation might change because some program might have bugs. So the implementation of the function might need to change. But the interface remains the same. So this is the benefit of separating interface from implementation. So one of the principles of the object-oriented programming is to hide information. And the three things are the same: data abstraction or encapsulation. The three things are the same. The users do not need to know the implementation details. The users only need to know the interface. And this slide compares procedure-oriented programming vs object-oriented programming. And the procedure-oriented programming is like what we have done in the assignments. In the assignments, we write functions to solve problems. This is the procedure. Procedure means function. This is function-oriented programming. While object-oriented programming means we create data types, and this data type has data and the functions. So you can use either POP or OOP to write programs. If your problem is simple, you can use POP because POP is easier to write. For example, if your problem is simple, you don't need to use mutator and you don't need to use mutator and accessor to modify the member data. You can use a structure to directly access the member variable. This is more convenient. So So it depends on your applications to use POP or OOP. If you want to protect your data, then you can choose OOP, because OOP can have some mechanisms like the private label to protect your data. So if your applications need to protect user data, then you can use the object-oriented programming. You can also use POP to protect user data, but this requires a lot of works. If you use POP and also want to protect user data, you need to write a lot of code. And this slide compares POP and OOP. OOP is data-centered. OOP focus on user data, while POP focus on algorithms. For OOP, the algorithm still exists, but the algorithms are made to fit the data. And for if we want to write a program to solve some problem, we usually define many objects, and we also have to design how they can interact. This is like the right-hand side figure in this slide. In this slide, we create 3 objects, and the 3 objects communicates. We need to design functions to communicate these objects. And we have finished this chapter. We have finished structures and classes. And next, we will learn constructors. Constructors are functions to initialize member variables. This chapter has 2 parts. The first part is about constructors. The second part is about tools, about classes, including const, inline, and static keywords. And first, we will learn constructors. Constructors allows us to initialize member variables. And constructors is a special member function. This member function have the same name as the class. And this function cannot return a value, not even void. So there is no return data type of the constructor. In this example, day of year is a constructor. This is a member function. The function name is the same as the data type. And this function does not have a return data type. So you see, day of year has no return data type. And the main purpose of constructors is to initialize member data. And other actions are also possible. And the constructor is a special member function. It is automatically called when we declare objects. So for this example, we can define a constructor to initialize the member data. And this constructor has two inputs, month value and the day value. And inside the function definition, we assign month value to the member variable month. And we assign day value to the member variable day. And when we declare variables, we use day of year to declare variables, date 1. And after date 1, we can add parentheses. This will call a constructor. Date 1 parentheses 74. This will call the constructor with two inputs. And 7 is copied to month value, and 4 is copied to day value. So after this declaration, date 1 dot month is 7, and date 1 dot day is 4. So in this example, I define I declare a constructor, and this constructor has the same name as the data type, and this constructor has two inputs, and this constructor has no return data type, and I assign month value to the member variable month, and assign day value to member variable day. And when I use day of year to declare a object date 1, and after date 1 is a parenthesis. This syntax will call the constructor. So 12 is month value, and 27 is day value, and the 12 is copied to months, and the 27 is copied to day. And then I call the member function output, and this function output will print the value of its member data, months, and the day. So the output is 12, 27. And you can also create another object date 2. I create another object date 2, and I also call the constructor. And then the member of date 2 is 12, 25. So if I call date 2 dot output, this statement will print 12, 25. And we know that each object has its own member. So the member variable of date 1 and the member variables of date 2 are independent. So date 1 has its own members, and the date 2 has its own members. The two objects are independent. And the day of year, the constructor is a member function, but we cannot directly use the dot operator to call constructor. So it is illegal to write this. It is illegal to write this because we cannot call constructors like member functions. The constructors are used implicitly like this. We do not use dot operator and the function name to call constructor. So this is an implicit call of constructors. And later we will show how to explicitly call constructors. Later we will show how to explicitly call constructors. You can also try this example. uh, if you declare a variable without parentheses, if you declare a variable without parentheses, then we will run this will call the default constructor. And because we have not defined the default constructor, so the compiler issue error message. And the time is almost up, so let's end here. And the next class we will finish the introduction of constructors.